Hi, my name is Mike, and I'm an application support engineer with Agilent Technologies. This short video will show you how to calculate the DC voltage specifications for one of our popular DMMs. Our first slide shows you a segment of the datasheet for the 34410 DMM. This is showing you the specification or accuracy table for DC volts and part of our AC volts. For this example, we're going to determine the specification for DC volts for an 8.5 volt input signal. And the temperature of our DMM while we're making this measurement is 30 degrees C. The first thing we need to do is determine what voltage range we're going to be using, and this will help us determine which row we're going to be using on our table. It's very simple to determine this. You just take the input signal, being 8.5 volts, and go to the next highest voltage range. In this case, that's the 10 volt range. Our next step is to determine which calibration cycle we want to use, and this will determine the column in the table. It is very typical for most customers to use the year calibration cycle, and that's what we will be using in this example. However, if you needed a more accurate specification, you could use a shorter calibration cycle or a more accurate DMM. In the case of Agilent, we have our 3458, which is an 8.5 digit DMM. Now that we know both the range and the calibration cycle, we can determine our specific error terms in the table. Using the general formula, we can calculate the error specification. In this case, we have 0.003% of reading error, and we have 0.0005% of range error. And that calculates to give us a total error of plus or minus 305 microvolts. In some situations, you may need to add an additional error term, and this is the temperature coefficient term. The way to determine if you need to use this is you take the temperature of calibration, which is Tcal. In this example, it's 26 degrees C, and you take the difference between that and the temperature that you're operating the DMM at, which is 30 degrees C. In this case, it's only 4 degrees, so we do not need to use this additional error term. So our final specification is 8.5 volts plus or minus 305 microvolts. However, in this example, the Tcal is 23 degrees C, and so the difference between that and the operating temperature is 7 degrees. We have an additional 2 degrees C that we need to compensate for. So we take the temperature coefficient terms, multiply it by the number of degrees C that we need to compensate for. In this situation, again, that's 2 degrees, and then we get the final additional error term. In this case, it's plus or minus 105 microvolts. So our final specification is 8.5 plus or minus 410 microvolts. This concludes the short video describing how to determine the DC voltage specification for the 34410 DMM.